Hey, it's Greg Getter. I wanted to give you an update about my DIY smart speaker project that I'm building that connects to the OpenAI Realtime API. This project is meant to be a lot like an Amazon Echo or Google Home device, but it's open source and it connects to the OpenAI Realtime API, which is way more conversational than these classic smart speakers. I've been tinkering with the project over the last week or so, and I was able to get the device built, connected to the real-time API, and sending audio both ways. Things don't work perfectly yet, but it's a start. Let me jump right into it with a quick demo so you can see where I'm at right now. Hey, what's the foggiest neighborhood in San Francisco?
The foggiest neighborhood in San Francisco, considered to be the Sunset District. This area is known for its frequent fog due to its location near the Pacific Ocean and its prevailing weather pattern.
If I wanted to climb the steepest hill in San Francisco, where would I go?
If you're looking to climb the steepest hill in San Francisco, you'd want to head to Filbert Street, particularly.
Couldn't I just take the cable car?
Yes, you could certainly take a cable car for a less strenuous way to experience San Francisco's steep hills. The Powell Hyde Line, in particular.
But isn't that dangerous on a rainy day?
Riding a cable car in the rain can be a bit more challenging, but it's generally safe. They're experienced crews and are built to handle San Francisco's variable weather. However, it's always good to be cautious. The steps and grips can get slippery, so hold on tight and be careful.
What's the weather normally like in San Francisco in November?
In November, San Francisco's cool and can be windy. In November, San Francisco's weather is typically cool and can be to low 6, around 13 to 17 degrees Celsius. There might be some light rain, as November is part of the city's rainy season. Fog is less common than in the summer months, but it can still roll in, especially in the early mornings and evenings. It's a good idea to dress in layers to stay comfortable throughout. As you can see, you're able to press the button on the top of the Adafruit voice bonnet to start and stop your recording. The first press starts the recording, and the second press stops it. Subsequent odd-numbered presses will stop any audio from playing and start recording, and then even-numbered presses will stop recording and wait for the real-time API to respond. Now, as you can see, sometimes I have to press the button 2 more times to get it to actually play, and you may have noticed that the audio actually skips sometimes as well. It's taken a lot of work to get it to this state, at least an hour per day of coding and trying different things out, but I'm going to have to keep tinkering to get the button presses working more reliably and things smoothed out. Now, you might be wondering why all of this is based on button presses right now. Shouldn't a smart speaker always be listening and respond dynamically? That's the ideal state we want to get to. I envision having a wake word, like when you say Alexa or Hey Google, you would say something similar, and the idea is that would wake up the device. When the device is listening for the wake word, it wouldn't be streaming audio to the API. Instead, it would be using a different process to monitor all the audio only for that wake word. And then when it hears the wake word, it would open the connection to the API and start recording. That first button press essentially stands in for the wake word right now. I want to get the communication with the API right first before we start working on the wake word detection. The OpenAI Realtime API has something called voice activity detection, which essentially allows you to keep both an input and output audio stream alive at all times. In OpenAI's API, voice activity detection is done on the server side, which means you don't have to do the input processing on the device itself. The API would detect when it's being spoken to and output accordingly, and it would even handle interruptions on its own. So if you speak while it's speaking, it will stop speaking and process your new input. Because OpenAI only charges based on input and output tokens, you wouldn't pay 4 times the silence, you'd only pay for spoken words.
Now, the problem I encountered when enabling server voice activity detection was that it would respond to itself speaking. So it would constantly interrupt itself and start talking in an endless loop, like this.
Hello.
Hello, how can I assist? To better it seems it appeared there seems to be a bit it looks like
I think this could be prevented with echo cancellation in the Pulse audio driver on Linux. I started playing around with this a bit, but I haven't gotten that to work yet. So for right now, we're sticking with the manual voice activity detection and just using the button presses. So there's a lot of work that still needs to be done on the interaction front, but at least the button provides a starting point for a somewhat workable product, and it allows us to test other things while we refine the interface. The other issue I noticed is that the audio output sometimes skips. I haven't taken a deep dive into this yet. It might be something to do with the audio configuration, something like the sample rate, or it might be due to packet loss over the network. I'm not sure yet. If it is a packet loss issue, I might look at moving from WebSockets to LiveKit, which is a platform that enables more reliable real-time streaming applications. LiveKit is actually the platform that OpenAI is using to power ChatGPT's advanced voice mode on its desktop and mobile apps. And I believe the real-time API is pretty similar architecturally to advanced voice mode. And they have some guidance on their website about how to use the real-time API with LiveKit. I'm posting this project on GitHub as an open source project. So you can use the Python code I wrote to set up your own smart speaker, or you could modify it for your own needs. All you would need to do is supply your own hardware like the Raspberry Pi, the voice bonnet, and the speaker. If you want to follow along or make improvements, I'd very much welcome them. Right now, things are pretty hacky and need a lot of work. And if you try it and you run into trouble, please open an issue. And likewise, if you make improvements, please open a pull request so we can see if we can merge those changes into the main project. Right now, everything is pretty hacky, but I'm hoping to get that cleaned up once we've solved all of the issues that I mentioned earlier. And one of these videos, I plan on walking you through the code base and how things work in depth. I just want to get it to a stable place first, because if I do a video about that right now, it's almost definitely going to change. I could see a world in which this project develops into something like an Amazon Echo or Nest Home fully featured smart speaker device, but it's open source and driven by the community. A lot like the project Home Assistant, which is community driven, as opposed to something that's closed like SmartThings. With that said, I'd love to hear your ideas for what this project could turn into. Please let me know how you might use this in the comments section. Thanks for your time, and I hope you have a great day.